So anyway, basically the ester lab we're going to do tomorrow is one of the more dangerous things we're going to do, or the most dangerous lab we're going to do. And we need to get the notes on it today. Not necessarily the lab, but on what is an ester. How do we make it? That's what we're going to be doing. Look at that fume hood. We have all that stuff in there. And if you look back there, period 1, set up all of your distillation apparatus up there. Okay? So we're going to have all that stuff to do tomorrow. All right, but you don't know what it is yet. So we got to learn about esters. Now, we left off in our notes, conversion into esters was reaction number 2 under carboxylic acids. Now, I want you to just save a little bit of time here. I want you to do this. Just write this underneath that. Just write down C ester reaction. I was doing it again. Gee, first time. C ester reaction. And, of course, the board's going to be goofy again. It was fine a minute ago, but now it's not. C ester reaction.
Oh, my God.
All right, let's do the esters right now. I'm probably going to, I don't know how well it's going to work, because for whatever reason, on this particular thing, the pen is not working. I know, I'm missing it. I'm going to give it to you right now. It's right here. Okay. No, I...
Right. Yes.
It's amazing. Why do I bother talking?
Just with this chair.
Yeah.
Hey, good luck tomorrow.
This way.
And we can just all take a nap and we'll wake up happy.
I agree with that. Yes, Italy. Yeah.
Of course, it didn't help that this stupid pen decided to take today off. It won't work.
Yeah, stupid pad.
And the board. All last period I struggled with it, trying to get it to work, which means if I can't get this thing to work, you're not going to have... Well, who's missing today? Anybody?
No.
Celie's going to be missing this note because I can't... You're not going to be able to write on this board. It's so bad. But we'll see. Maybe not. All right, esters. Look at the formula for an ester. Okay? What does it kind of look like? It's very similar to what? One letter difference. One atom, one thing different. Yeah, the carboxylic acids. Yeah, the carboxylic acid was RCO(OOH). So instead of an R, you had an H there. Okay? Well, this is different. That R stands for a carbon, or a carbon group, a group of carbons. So what you've done is, an ester is a way to link longer chains. I could have this R group could be 20, 30, 40 carbons long. This one could be 20, 30, 40 carbons long. It's not going to be for the ones we do in the lab, but it can be. And in your bodies, you have a lot of ester links, all right, for different chemicals, all right, that actually form. In organic chemistry, it's a very, very important linkage, way to hook together longer chains and make, basically a polymer out of it. If I put the word poly in front of an ester, what do you get? Polyester. Yeah. You ever hear of polyester? You're probably wearing at least, most everything you're wearing is probably at least partly polyester, some synthetic fabric. Okay? Unless you have an all cotton, 100% cotton T-shirt on. Most of your T-shirts aren't even 100% cotton anymore. They're usually about, what's the point of having a polyester T-shirt rather than 100% cotton? What do the, yeah, the cotton shrinks, whereas the polyester won't. And also, cotton wrinkles more. Okay, let's see. We'll get to a lot more of that under polymers, but right now, let's talk about esters. All right, first of all, some properties of esters. All right, some properties of esters. Well, the first thing you're going to notice when you do this lab is how bad that stuff smells and how good your product smells. And I'm not pointing at Bulkley. That goes without saying. How bad the stuff behind Bulkley, well, that kind of goes without saying. How bad the stuff in the fume hood
Smells like Holden.
But many esters have pleasant, fruity smells. They will be recognizable. They will smell like a particular mint or fruit that you have all either smelt or tasted before. Or smoked, yes. If you guys smoke apples, yeah, that makes sense.
Smoked tops.
Mm-hmm. All right. So they have pleasant, fruity smells. By the way, remember, where is this going to show up? I told you already, two things you're going to see on the non-reaction test. One is going to be a list of these guys. I can list alkanes, alkenes, alkynes, alcohols, carboxylic acids, and esters so far. That's all we've got. And there's more to come. But I can also list, and I will have a list of the matching section of the properties. So if I ask you, which of these guys is going to donate hydrogen ions or form hydronium ions? You would say carboxylic acid from last time. If I ask you which of these guys up top have pleasant fruity smells, you will say esters. Got it? All right. Something else about the properties of esters? They are the organic equivalent of a salt. Now, I'm going to spend some time on this when I explain to you what that means by that. We have seen salts before. Okay? We saw a salt formed from a reaction of an acid and a base in Chem 1. The most famous being, what's our most famous acid? Hydrochloric, HCl, right? HCl. What's our most famous base? Don't write this down. Our most famous acid is HCl. What's our most famous base? NaOH. If I put those two guys together, use your head. What am I going to get? A salt, right? NaCl, and HOH, which is water, H2O. All right. So that's what we've seen before. The inorganic reaction would be an acid plus a base, yielding always, and when I say, what do you mean always? You're always going to get NaCl? No, you're always going to get a salt and water. You're not always going to get NaCl and water, because you can have a different acid and you can have a different base. But you're always going to get something that's called a salt and water. Okay? So, for example, HCl plus NaOH gives you a salt plus water. Now, the salt we're getting in this case happens to be NaCl because I use hydrochloric, our most famous acid, with sodium hydroxide, our most famous base. But if I use sulfuric acid, and so instead of it being HCl, don't write this down, it was H2SO4, the difference would be I wouldn't get, and reacted with sodium hydroxide, I would get sodium sulfate, which is still a salt. And I would get hydrogen and OH coming together. It wouldn't be H2OH. Remember, we used to make that mistake. It would be water. The formula for water is still H2O, but I'd have to balance it. So either way, that was Chem 1. That was all of Chem 1. Now, how does that relate to Chem 2? How does that relate to esters? Well, can we think of a guy, inorganic, that also acts like an acid? We just got him yesterday. What is it? Or last week. What do we call them? The things that are acids, the things that donate hydrogen ions. What do we call them? Carboxylic acid, right? And do we know somebody inorganic that has an OH on it? We certainly should. And alcohol. So if you take that carboxyl, if you look on the left side of that fuel, there are alcohols. On the right side of that fuel, there are carboxylic acids. If I take those two guys together, I react them together. I get an ester and I get water. Exactly the same as what you would do when you take your inorganic ones. And varies in a much similar way, people. The product is less, or is non-harmful, if you think of it this way. Does anybody want to drink sodium hydroxide? You want to drink lye? No. That's the stuff they put in Drano. It'll kill you. You want to drink hydrochloric acid? No. But can you eat salt? Yes. Do you want to drink carboxylic acids in their pure form? No. Do I want to drink alcohol? Don't answer that.
Yes.
No. Fact is, alcohol is a poison, even the kind we do drink in small amounts. You know how your body reacts to alcohol? It's very simple. It shuts down. Your brain shuts down. You first shut down non-essential functions like thinking.
Is that what happened?
That's basically what happens to Bulkley every day. So he
he
doesn't need alcohol. He doesn't need alcohol. It's already shut down. Anyway, but alcohol is a poison, and your body reacts as it should to poisons. It's going to try to protect those different functions. So it's going to shut those things down. But of course, eventually, you start shutting down even the worst of the most important ones, like breathing. You lose consciousness, and then you can. I told you in Bloomsburg University back when I first started here. I think in the first 5 years I worked here, there were like 3 or 4 kids who died of alcohol poisoning from hazing stuff that used to happen all the time from sororities and fraternities. Idiots who try to drink 21 shots on their 21st birthday and they weigh 90 pounds. You're going to kill yourself. You can't do that. Hopefully you'll throw up. If you don't, you're in trouble. All right. But anyway, esters. Just like salts, I can eat. They are used to flavor and scent things. All right, you'll see these esters in packages of gum and candies, and as an artificial flavoring and an artificial scent.
Go ahead, Paul. Get him.
Okay.
I think he's got. Yeah, he's got gum.
If you, by the way, you'll be able to tell Well, actually, you'll be able to tell because it ends. I'm going to show you how to name these guys. If you look at your products in your shampoos, your lotions, or your candies and gums, if it ends the way these esters end, it's an ester. I'm going to show you how to name them. Okay, so you'll be able to tell.
Keep that out, Holden. I got it.
Oh, wait, I'm not done with that. I wanted to show you, I want to write and say that this is where things went really crazy, so hopefully my pen will work here. I want to write in here what's going on. Just like I have an example using this guy, I want to use the general formulas of the carboxylic acid and the alcohol. So for the carboxylic acid, all right, it'd be R, C, double bond O, O, H, right? That's a carboxylic acid. Everybody agree? Carbonyl group, OH, there it is. You saw him last time we had class. You add an alcohol to that. We're going to call this guy R prime OH.
What's that?
That prime means, at prime, R prime OH means he's a different R group. He could be the same number of carbons or fewer or more than that guy over there. And then I'm going to add, and by the way, you'll notice something else. I didn't show it on here because I can't. It's kind of a pain to make double arrows. But these guys are reversible reactions. So they go both ways. Yes, all of the ester reactions are, yes. All right, so what am I going to get? Watch what happens. Same as what happened over here. The H and the OH came together to make water. And then these two guys came together, right? Same thing. The H and the OH come together to make water. It's already off, but not too bad yet. They make water. And what else happens? This R group gets linked to that O and the rest of that group. This is why you can link these larger groups together. So you get R, C, double bond O, O, R prime. Now, see, it's going off a little bit, but hopefully you got this one in at least. Can you read that? R, C, double bond O, O, R prime plus water. So you get your ester. That's what an ester is. There it is, right up there. And again, the ester being the salt equivalent is not dangerous. Alcohol is poisonous. Carboxylic acid is poisonous. You're not going to want to drink or smell any of those guys. They stink and they are harmful, just like hydrochloric acid and sodium hydroxide is. Okay? But we can eat salt and we can smell these esters and they will smell good. Matter of fact, plants naturally make these things. All right? Like, that's what makes an apple smell. That's what makes an orange smell, the ester that's in it. All right? Okay. Now, because I changed this and trying to get it to stop doing this goofy stuff. Let's talk about how to prepare an alcohol, or how to prepare an ester, I should say. Okay? Now, once again, we'll see if it works.
What was it?
You guys already have those in there, correct?
Yeah.
All right. So there's your alcohol plus your, your acid plus your alcohol gives you ester plus water. Let's do an example. This is under your first example here. Okay? Try this guy.
Fix your mustache.
Huh?
Fix your mustache. There you go. There. Y'all get that? I can't look at you and not laugh. What'd you put in there? I got a spray thing.
Okay? It's pretty good for the hair.
It is pretty good.
All right. Take these two guys, write them down. Now, I want to do two things here. I want you to see if, I think most of you will get the correct products here. Okay, I want you to try writing the correct products. The naming, you don't know how to name them yet. I'm going to have to show you how to name this guy. But anyway, try doing that one on your own first. See if you can finish that guy up. What do you get when you add those two guys together? Yeah, by now, these should start to be making sense to you. Organic reactions are all about common sense. They're not just about memorization. You can see what's going to happen here, right? I hope. But there is a mistake people make. For some reason, they leave something out when they redo this, when they go to try it. And again, if you're not trying it on your own, you're not going to make that mistake, and then you will make it on the test. So you want to try it now, and then see if you did it right. hopefully you all realize we're going to get water over there. The hard part is figuring out how these guys go together. It's not that hard. I hope you all did this. Did you remember to put the O here? People, for some reason, just skip it. They just link the carbons together. Okay? You can't skip that O. There's still an O there. That's what makes this guy an ester. Okay? Can you name this guy? Sure. What's his name? 4. What is it? It's 4, but it's an acid. What would you call it? Butanoic acid. All right, we just got that the other day, so you're not as familiar with that one. But certainly everybody knows this guy over here with the alcohol. What is he? Methanol. And this one here? That you don't know. You couldn't possibly know. I'm going to show you how to name him. What you do for this guy, and I'm going to give you the rules. Notice down below in your paper, I have the nomenclature rules. You're going to name the guy that came from the alcohol first. That will be the methyl group. You name the alkyl group from the alcohol first. Then you name the alkane from this guy, and then you put an OATE ending. So this guy is called methyl, that's an E, methyl butanoate.
Is that all the word?
Yeah, methyl butanoate.
What?
Okay? And I'll show you, I'll give you the rules on that in a second.
Wow.
All right.
But isn't the ATE? And then
Yeah, well here's the actual rules. Let's do the actual rules. Write these down.
this is the nomenclature, guys.
These are the rules. Name the alkyl group from the alcohol first. That's what we did. We named the methyl that came from the alcohol. Okay. And notice how I phrased this. I didn't say name the alkane. That would have been methane. Okay. I said name the alkyl group, which is methyl. Methyl. Okay. So I call this guy methyl in this case. Next guy, name the alkane from the acid, second. So, butane. Notice I didn't call him butyl. I call him methyl, butane, and then I add the suffix OATE. Methyl butanoate. Okay?
Is it on the pack of gum?
If you see anything that ends in in ATE even, because, for example, I told you a lot of these guys are named by common systems. Many of these, even esters, are instead of calling them, for example, methyl butanoate, they'll just call it methyl, well, here, the one I'm thinking of is acetyl salicylic acid together with methyl alcohol will be methyl salicylate. So you just use ATE instead of OATE.
Anything?
Anything in an ATE there for the scent or the smell or?
No.
No. You will. I'll show you. We're going to make some tomorrow, and you will be very familiar with them. All right? Okay, let's do some examples of the naming. Okay, while we're here. I want you to put these, I have room for what? 2 examples?
2 examples. Possibly a third.
All right, let's do this. Try this guy first. Under the example, I'm just going to do it right here.
Example.
Oh,
All right. Oh.
there we go.
What? Were you imitating him singing before? What were you doing when you were holding your hand up to your mouth? When you were talking about the brewery? Were you singing?
Okay, try that guy.
I was like,
Took it off the bomb.
You have to scream that.
yeah,
All right,
I don't want to scream right now. The camera's on.
No, the camera's on.
Oh, it is?
Yeah.
Oh.
It's on, I said. Not off.
Well, thanks.
All right, try that guy. What would his name be? Now, again, try him, Dayton. Try him. Try naming him. It's not that hard. But there is a mistake you'll make. And I want to make sure you guys don't make it. This is under the example for the notes. I mean, for the nomenclature stuff. What would I call this guy? See, there's two mistakes I can see being made here. Okay. I don't know if if everybody's going to make them. Well, let's see. One is naming them the correct direction, which one comes first. And you all chose the ethyl to come first? Good. Even though I wrote it, the other one was written, I think I erased it, but the other one was written with the ethyl on the other side. It doesn't matter which side. How do you tell which guy came from the acid? He had this guy, the carbonyl group on him. So this is the guy who came from the acid. Even without seeing the actual reaction, I know this guy is ethyl. That's the part that came from the alcohol. And then here's your second mistake. People don't include that carbon. They call it ethyl ethanoate. Is that ethyl ethanoate?
Negative.
No, propanoate. Okay? And one more example real quick.
Remember, this is under nomenclature.
Last one, make it a short one. That should be, this just prove to me that you know what you're doing if you get this guy right and we're all done. And again, the common name for this guy, they wouldn't call it ethanoate, they would call it acetate, methyl acetate. All right, I know because acetic acid is ethanoic acid, and use a common name for that. And then instead of OATE, just ATE. All right, that's not uncommon to see these kind of the common naming systems being used instead of the UPAC system, but that's the UPAC. That's what I'm teaching, and that's what you should have to put on the test, okay? All right.